So balancing redox, this is called the half reaction method. So basically what we're going to be doing is we're going to be splitting our reaction into the oxidation portion and the reduction portion. We're going to balance them separately, and then we're going to add them back together. Okay, so these are the steps that are involved. We'll just read over them. They won't make a lot of sense until we actually do them. So when we're doing them, just keep referring back to the steps. So the first thing is to divide them in half. Then we're going to balance all of the elements other than hydrogen and oxygen. We always save hydrogen and oxygen for last. Once we have balanced everything else, the way that we balance oxygen is we add water to whichever side of the equation needs it to balance it. And then because we're adding water, we're adding H2O, our hydrogen will be out of balance. So we do that by adding hydrogen ions to the appropriate side. Then when that is done, we balance our charges with adding electrons. So the difference between these and our regular balanced equation is we also have to balance our charges. So in other words, it has to be the same overall charge on each side of the equation. Sometimes that'll be positive, sometimes that'll be negative, sometimes it'll be neutral. Okay, it just depends on what the equation looks like. And then, after we balance all the electrons, the very last step is we have to make sure that for both the redox and both for the oxidation and the reduction, you have to have the same number of electrons being exchanged. So you may have to multiply one or both of the half reactions by an integer so that you have, say, 5 electrons or whatever, however many you need for both of them. So best way to do it is just do it, because when reading your steps, you're like, I have no idea. It's actually not that hard. It's a step-by-step process, but it just seems confusing at first. Okay? So then we would cancel out, once we add them back together, we would cancel out any common terms and then get the final one. Now, if it's acidic or neutral solution, you're done after step 7. Okay? But if it is a basic solution, we have to do this extra step. So underline that only if this is a basic solution. Because if it's a basic solution, we can't have free hydrogen floating around because that would make it acidic. So we would add hydroxide to both sides of the equation, same amount, and then any hydroxide and hydrogen that we had on the same side would make water, and then we would cancel out the common terms. And then the last thing is to always check your final equation, make sure all your things are adding up the same. If I've got 4 oxygen on both sides, and also double check that your charges are balancing.
How do you know that it's a basic solution?
It'll tell you. It has to tell you. Yeah. If it doesn't tell you, you assume, usually it will tell you if it's acidic or basic. If it doesn't tell you, you assume acidic or neutral. You only would ever do basic if it says this is in a basic solution, or if it's like said parentheses basic. Okay? Because then you would do this. And so we're going to do both kinds. Okay? So the first one is this, got permanganate and iron 2 going to iron 3 and manganese. And this is where knowing what those oxidation states come in handy, so you can kind of tell. But honestly, if you can pick out one of them, you can know what the other one is doing. Because if one is being reduced, the other one's got to be oxidized. Okay? So when you're doing these, your electrons should appear on opposite sides of the equation for each one. They should never, if you're ever doing this and you have the electrons in both reactions on the same side, then you've done something wrong, because it can't happen that way. So we're going to do the easy one first, and we're going to do the Fe2+, and I'm going to do this in 2 different colors so we can kind of distinguish between the two. So we have Fe2+, and it's going to Fe3+. Okay? So our iron is already balanced, so now we just need to balance our charges. Okay? And I have a 2+ on the reactant side and a 3+, so I'm going to need to add 1 electron right here. Okay? Does everybody understand that? And that's just to balance the charge. So if that iron lost an electron, is it being oxidized or reduced? Oxidized. Remember, oil rig, oxidation is loss of electrons. So this is our oxidation. So we're going to put that over there. Okay? So then that leaves our permanganate. Let's do this in blue. MnO4 minus is going to Mn2+. Okay? So if we knew, well, we know that manganese there would be a negative, being a +7 because we just did that one. Okay? But you don't add the electrons into the end. Okay, so I have 4 oxygen on the reactant side, so I'm going to have to add 4 water over here. So now my oxygen is balanced, but my hydrogen is not. So that means I'm going to go over here and I'm going to write 8 hydrogen over here. So now all of my elements are balanced. So now I need to balance my charges. Okay? So over here I have a 2 plus on the product side. So product side is 2 plus. What is my charge on the reactant side? 7 plus. Because I have these 8 hydrogens, but then I have a negative. So I need this side to be 2 plus. So how many electrons would I add? So I would add 5 electrons here. Okay? So now my charges are balanced and all of my elements are balanced. So it is gaining electrons because I'm adding 5 electrons to it. So this is going to be our redox portion. Okay? So is everybody with me so far? Yes? Okay. So now we look at this and we see that they are not balanced as far as this has 5 electrons here, this has 1 electron. Okay? So what I'm going to need to do to iron is I'm going to multiply this one only by 5. Because I need my electrons to be the same in both the oxidized and reduced. Okay? So now I'm going to rewrite everything, and I'm going to say 5 Fe2 plus 5, sorry, I was making that 5 3 plus, 5 Fe3 plus 5 electrons. And then I'm going to add to it my original redox because I didn't change it.
So why did you change the yields arrow into just a plus?
Oh, I didn't mean to.
Okay.
Yeah, that was just a mistake. Sorry. So now I'm going to cancel out my 5 electrons because they appear on both sides. And for this particular one, that is oh wait, I need all that cleaned up. Yeah, that was an important thing to remember. Sorry. So the only thing that appears on both sides is the 5 electrons, so I cancel those out. So my final balanced redox equation would be 5 Fe 2 plus 8 hydrogen plus the manganese. I mean the permanganate, that's not manganese. And then 5 Fe3 plus Mn2 plus I'm running out of room, 4 water. And that would be my final balanced redox equation. Okay. Now I want to double check that everything is the same on both sides. So I would start with I have 5 iron ions, 5 iron ions. Check. I've got 8 hydrogen here. 4 times 2, I have 8 hydrogen here. I have 4 oxygen here, and then I have 4 oxygen over here with the water, and then 1 manganese, 1 manganese. So all of my elements are balanced. So now I would check my charges. My total charge over here is 5 times 2 is 10, plus 8 is 18. Okay, but then I take that off, so I have 17. So I have a total of a 17 charge, plus 17 on my reactant side. And then over here I have 5 times 3 is 15, plus the 2 on the manganese, and then I would have plus 17. So my charge is balanced and all my elements balanced. Questions?
So if it doesn't all add up, you just like...
If it doesn't, if you get to that point, then you got to go back to your original half reactions and check and see if you did something wrong.
Okay, so your half reactions are just splitting apart between...
Yeah, so you do your redox separately, your reduction separately from your oxidation, and then you add them back up. Okay? Otherwise it's really hard to do it without doing it that way. Okay? There are some redox that you could do very simply by not doing that, but especially if you got oxygen disappearing, like it disappeared completely out of the permanganate, you need to do them as a separate. Okay? So let's do one that's basic so we can practice that one. Okay?
For water, it's neutral, but like how do you get those half electrons?
So for when I was doing them separately.
Like when we were checking to make sure that they balanced, it was like 17 and 17.
Oh, so if you look at the charges, okay, I see what you're saying. I'm just literally adding them up together. So like this right here, I had 5 times 2, that's a 10 plus total, right? Then I had this 8 plus, and then I had a negative 1.
Yeah, but then all the others.
But so I had 5 times 3 would be 15 plus this 2 plus. That's an overall charge of 0, so it doesn't add to the charge.
Okay, so you don't add. Okay, that's probably what
Yeah, no, it's saying it's things that have charge on it. If it's a neutral compound, it doesn't have a charge. Yeah, and sometimes it'll work out to be neutral, and you got to get the other side to be neutral. It just depends on the reaction. Okay, so let's do one that is basic. So this one is in a basic solution. So this one's gonna look a little different. So in this one I have Ag plus the Cn minus going to AgCN2 minus. What about that oxygen? I'll show you. Yeah, sometimes it won't show you on the other side, and you got to add it in. So I don't want that to confuse you. Let's do this one first. My Ag is balanced, but now my Cn's not. So I need to put a 2 right here.
So
I didn't
you
leave
just
myself
go
enough
those
room.
Go together because there's an AGC on the other side.
That's the only way they could go. But I need to erase that and give myself some room so y'all can see that better. So Cn minus. Okay. So I need to balance with electrons. So how would I do that? Where would I put the electrons?
On the right side.
And how many do I put?
1.
Just 1. Because I need this side to add up to a negative 2 total, because this is a negative 2 over here. So now for oxygen, so do O2, and then I'm just going to leave it blank for now. Okay. The only way I can balance my oxygen is to make water. So I would do 2 H2O, and then I need how many hydrogen? 4. And so now I'm going to balance my charges. So I have 0 over here, a neutral charge of 0 on my product side, and I have a 4 plus over here. So I'm going to add 4 electrons. Okay. Now I see that I have 4 electrons here and only 1 here, so I'm going to multiply this whole thing by 4. And then I'm going to add them back up together. So I would have 4 Ag plus 8 Cn minus plus 4 AgNCN 2 minus, and then plus 4 electrons. And I would add to that 4 electrons plus 4 hydrogen plus oxygen is 2 H2O. And I am going to run out of room. My electrons are the only thing that I can cancel out, so I would rewrite this as 4Ag plus 8 Cn minus plus 4 hydrogen plus oxygen is 4. Okay, but this is a basic solution. So I have to add however many hydrogen I have, free hydrogen, which is right here. I have to add that many hydroxide to both sides of the equation. I can't just add it to one. So I'm going to say plus 4 hydroxide plus 4 hydroxide. And this is where I'm going to run out of room and need room. Okay? So I'm going to add a new page and rewrite that on the next page, because y'all still have room, I hope, but I don't. Okay?
I thought solar had a charge.
No, not over here. It doesn't. It's elemental.
It's a solid.
Yeah, because it's a solid. When it's a solid, it's elemental. It doesn't have a charge.
Okay.
Yeah. Anything that's a free element, remember, doesn't have a charge. So it's 0. Okay? So someone help me remember when I get to the next page. We're going to rewrite that.
It's still there. Here you go.
It's like pausing on me.
Cut and paste, like draw a circle
Oh,
out.
I don't know if you can do that.
You lost it.
I did, but that's okay. I can get it back. I can get this back. So I had
4AG
4Ag
plus 8CN negative
plus 4 hydrogen
Yes.
yeah, plus O2.
Plus O2. And it went to 4AgCN.
2, oh, whoa, there you go.
It's like, I snuck it in there.
Plus 2H2O.
Plus 2H2O. Okay. And then I said because this is a basic solution, we needed to add in 4 hydroxide to both sides. Right?
Yeah.
Okay. All right. So when on the product side, the hydroxides are not going to add to anything. They're the same. But if you look right here, what happens if I add 4 hydroxides to 4 hydrogen? What do you think I make?
4H2O.
I make 4H2O. Okay? They don't cancel out. What's so funny? Okay? Now if I look, because right here I have 4 water and over here I have 2 water, what do you think they're going to do with each other? Cancel out, yes. So this is going to cancel out completely, and then this is not going to cancel out but become 2.
Oh, gosh.
So my final equation would be, yeah.
Okay.
I'll go back over what we did.
Okay.
So this is going to be 4Ag plus 8CN minus plus 2 water plus oxygen yields 4 of these plus 4 hydroxide. And I ran out of room there, but there's a negative sign right here. I'll just write it. Okay? So now we double check. I have 4 silver on both sides. I have 8 cyanides on both sides, although that doesn't look like cyanide because
That's 2O.
I wrote it too close together. There. Now you can see it's a cyanide. So I have 8 cyanides on both sides. I have 4 hydrogen right here. 4 hydrogen right here. 2 plus 2 oxygen. So total of 4 oxygen, and I have 4 oxygen over here. So all of my elements are balanced. Now let's check my charges. Okay? I have 8 negative and 4 negative there and 4 negative there, so a total of 8 negative. So that balances as well. Okay? Now, questions? Yes? If the charges do not balance up, what happens? Is that what you asked? Then you go back to the beginning and see where you messed up. Yeah. If your charges don't balance at the end, you've done something wrong. I mean, it literally is a double check. They have to balance out. Okay? So if you get to the end and it doesn't balance, then you have to go, what did I do wrong? And then you should go back to both of your half reactions and double check everything. Okay? All right? Any other questions?
Wait, so what happened with the hydroxide?
What happened with the hydroxide? Okay, so when it's basic, we had these, I'm going to change color so I can point with that. So I had these hydrogen right here, and because it's basic, we have to add hydroxides to both sides, so we added here and here. Okay, well when I add 4 hydroxides to 4 hydrogen, I get water. Okay,
4, right?
I had 4 right here. Okay, but because I had this 2 water here, those went away and they canceled out 2 of those. Because remember, what's on opposite sides cancel each other out.
Okay.
So that's why it went to 2, not 4. Okay, if there hadn't been any water over here, it would have stayed at 4. But since there was 2 on the product side, it canceled out 2 of the reactants. Okay. Any questions? Any other questions?
Is that it for you?
I think your next 2 are left side activities. Let's double check. Yeah, because we'll do electrochemistry and practical applications. Yeah, that was it.